Welcome to Numerical Methods and Integral Transform course. In the previous lectures, we discussed about forward differences, backward differences and central differences. So, forward differences, there will be two categories, Newton forward and Newton backward. So, Newton forward, the backward category, Newton backward interpolation. So, these central differences I have given the formulas yesterday session. So, now how we are going to be use the central differences? And how we are going to be evaluate when we are going to be use this particular central differences concept. So, in the central differences, there are two kind of the formulas which we discussed in the last session, that is Gauss forward interpolation, the second one is Gauss backward interpolation. So, the given data, these central differences, if it is located, that unknown point is located around middle of the table. So, look at the given data. So, the given data when x is equal to 1, something 15.3, when x is equal to 2, 15.1, when x is equal to 3, 15, when x is equal to 4, 14.5, when x is equal to 5, the 14. So, the given data something like. So, now we need to be find f of 3.3. So, look at f of 3.3 is located around middle of the table. So, since 3.3 is located middle of the table. So, if it is located around middle of the table, we are going to be use central differences concept. So, in the central differences, there are two categories. Now, based on the p value, we need to be decide. So, which method we are going to be use, either Gauss forward or Gauss backward. So, we need to be find p value first. So, I will be find p value. So, p value we can able to find using of this p is equal to x minus x naught by h, where x is what value we are finding, that will be called x, that is 3.3. So, this x naught is nearest value in the given data. So, nearest value in the given data. So, which is the nearest? 3.3 is nearer to 3 value. So, that is the reason why we are considering as x naught value is 3 divided by this h is successive approximation difference. So, x difference, x value is difference like x1 minus x naught, x2 minus successive x series difference. So, 2 minus 1, 1, 3 minus 2, 1. So, obviously, this will be equispaced. So, 1. So, therefore, if you simplify, we are going to be get p value is 0.3. So, this 0.3 is lies between p and 1. So, positive value lies between 0 and 1. So, therefore, we are going to be use Gauss forward interpolation formula. So, now first we need to be construct the differences table. So, based on the differences table, we need to be use this Gauss forward interpolation formula, substitute in that. So, therefore, we are going to be get f of 3.3. So, the given data, based on that we need to be construct the table x, y. So, given data your x value is 1, 2, 3, 4, 5. So, the respective y value is 15.3, 15.1, 15, 14.5, so 14. So, delta is the first order difference or delta y. So, notations which we need to be give first. So, nearest value we need to be consider as x naught, that we already consider, this is as x naught. So, therefore, this is x1, x2. So, before these values we denote with negative x minus 1, x minus 2. So, that respective corresponding y values denoted by y naught, y1, y2. So, before these values we denote with negative y minus 1, y minus 2. So, now we need to be find out the difference of these two. So, difference of this minus this 15.1 minus 15.3. So, therefore, this value is negative minus 0.20, 15 minus 15.1. So, therefore, this is also negative minus 0.10. 14.5 minus 15. So therefore this is also minus 0.50. So 14 minus 14.5, difference of this 0.50. So first we need to be construct the table, then we need to be give the notations. So second order differences. So difference of these two, minus 0.10 minus of minus plus. So 0.10 plus 0.20 will be get 0.10, minus 0.40 minus of minus plus this 0.40. Simply we need to be find out the difference, 0 minus 0.50 minus of minus plus. So therefore we will get 0, like the second order difference of these two, minus 0.40 minus 0.10, this is 0.3, difference of these two, minus 0.4. So delta power 4 minus 0.4 minus this. So finally you are going to be get the particular value. So this is minus 0.40, this is 0.4 minus 0.4 minus 0.3, 0.7. So this is a way we need to be find. Now we need to be give the notations. So difference of these two, this is delta y minus 2, this is delta y minus 1. These kind of the constructing the table very starting sessions we discussed. So this is delta square y minus 2, this is delta square y minus 1, this is delta square y naught. So this is delta cube y minus 2, this is delta cube y minus 1. So this is delta power 4 y minus 2. So as I said, to evaluate f of 3.3, we need to be use the Gauss forward interpolation formula. The last session I said to construct or remember the Gauss forward interpolation formula easily by this technique. Look at, if it is a forward, just we need to be start with forward. So upward value. So if it is a forward, obviously we are going to be use the downward value. So this value and like one upward, just I am circling this value, just need to be remember, right? So just I am removing to avoiding the confusion. So whatever just I am writing now, that only just keep here, the remaining all symbols just I am removing, okay, right. So this is starting the value here, one downward value, upward, then downward value, then upward value. So these using of these values we are going to be construct the formula. Look at here. So yp is equal to the starting value here y naught, then it is a forward, we start with p delta y naught. So where the next value is upward, so it is a forward, we next value p minus 1 delta square. So p into p minus 1 by 2 factorial delta square y minus 1. Then the next value delta cube. So one increment to the positive side, p into p minus 1 to p plus 1 by 3 factorial delta cube y minus 1. So the next value, so previously p into p minus 1, now p into p minus 1, p plus 1. Next side negative increment, p into p minus 1, p minus 2. So p plus 1 by 4 factorial delta power 4 y minus 2. So we need to be substitute these values, So simplify this, you are going to be get that particular result. Now we will just going to be substitute that. So yp, so whatever the values in the last slide, just we need to be see and substitute in that. So there is y naught is 15, so 15 plus p into y naught. So where p value as we know 0.3, so 0.3 and delta y naught, as I said the second value delta y naught is minus 0.50, Now next p into, so p into p minus 1, 0.3 minus 1 by 2 factorial So delta square y minus 1, where delta square y minus is 0.40. So 0.40. Now p into p minus 1, the next value is obviously plus side. So p is 0 plus 1 by 3 factorial. So delta cube y minus 1, where we know delta cube y minus 1 is minus 0.4, minus 0.4. So same way you can extend p minus 1, p plus 1. Obviously p minus 1, p minus 2. So where previously p minus 1, p plus 1. So now p minus 1, p minus 2, p plus 1 by 4 factorial. The formula delta power 4 y minus 2, where the delta power 4 y minus 2 already we find, that we are going to be substitute. So this we are going to be substitute in the calculator and simplify. So you are going to be get yp value. What value we are finding? F of 3.3. So that you can also denote f of 3.3 value. If you simplify this, the approximately value you are going to be get 14.9. So this is the way we need to be use the Gauss forward interpolation formula. Basically, if it is located around middle of the table, now we need to be find the p value. Based on this p value, we are going to be evaluate, or we are going to be find using of Gauss forward interpolation formula this way. The similar way will be take one more example for Gauss backward interpolation. So when we use this, what is the situation to use this particular thing? So as the basic concept is same, the given. So we need to be find y value when x is equal to 1936. Use appropriate interpolation. So where the data is given, x is equal to 1901 and the respective y value is 12. When 1911, the respective y value is 15. So when 1921, the respective y value is 20. When x is equal to 1931, y value is 27. When x is equal to 1941, the respective y value is 39. When x is equal to 1951, respective y value is 52. This is the data is given. Now we need to be find 1936, which 1936 is located around middle of the table. So not exactly around middle of the table. It lies inside, basically it is interpolation. So which is nearly located around middle of the table. So since 1936 is located around middle of the table. So if it is located around middle of the table, we use central differences concept. So in the central differences, based on the p value, we are going to be decide either Gauss forward or Gauss backward. So how will be decide? Just we need to be find the p value. So where p is equal to x minus x naught by h, where x is for what value we are finding, that will be called x, that is what 1936 minus x naught. So nearest value, so x naught we consider nearest value as x naught in the given table or given data. So 1936 is located actually 1931, 31 to 41. So just you assume where it is located. So 30, there are how many points which will be lies between 10 points. If I add 5 points, 1936. Where if I add one more other 5 points, 1941. But exactly it is middle. So whichever you consider, it will be fine because it is exactly middle. But the same question, if you want to be calculate using of backward, p must be negative. So if you consider 1941 as x naught, you will be get negative, we can go for backward. If you consider 1931 as x naught, you can use the Gauss forward. So in the previous question we practiced Gauss forward. So therefore I am using now x naught as 1941 divided by length of successive values. Length of successive value is 1911 minus 10 will be 1911 minus 1901. The difference is 10. So therefore minus 5 by 10, which is minus 0.5. So, the value which is negative lies between minus 0 and 1. So, therefore, we are going to be use Gauss backward interpolation formula. The p values lies between, we use Gauss backward interpolation formula. So, we need to be construct the same table like the previous one. So, after constructing, then we need to be consider the table. So, where x is 1901, 1911, 1921, 1931, 1941, 1951. The respective y values 12, 15, 20, 27, 39, 41. Just we need to be find out the differences. 15 minus 12, 3. So, it is 5. So, 7, 12, 2. So, second order differences. So, it is 2, 2. So, 5 minus 10. Delta cube 2 minus 2 0, 5 minus 2 3, 10 minus 5 minus 15, delta power 4, 3 minus 0 3, 15 minus 3 minus 18. So, delta power 5, 18 minus 3 minus 21. So, now we are going to be consider. So, x naught we consider as 1941. So, this is what x1, the previous value x minus 1, x minus 2, x minus 3, x minus 4. The corresponding y value is y naught, y1. So, previous value y minus 1, y minus 2, y minus 3, y minus 4. So, that respect to also we need to be give the notations delta y minus 4, delta y minus 3, delta y minus 2 same. So, this is constructing the table common for all the methods. So, just we need to be give the notation so that we understand easily. So, substitution part will be get it easily. So, delta square y minus 2, delta square y minus 1. So, this is delta cube y minus 4, delta cube y minus 3, delta cube y minus 2. So, this is what delta power 4 y minus 4. So, this is delta power 4 y minus 3, delta power 5 y minus 4. So, as I said, use the Gauss backward. So, Gauss backward value. So, from the starting value onwards, just you take the upper value. So, this value. So, then down value. So, this value. Then up value and then down value. So, there is no down value. So, therefore, we are going to be stop this particular series and we are going to be write the formula. Look at the formula. So, starting value as same y naught. So, starting with p same. P delta y minus 1. So, it is a backward. So, increment with positive side p into p plus 1 by 2 factorial delta square y minus 1. So, next increment is negative side obviously p into p plus 1 p minus 1 by 3 factorial p into p minus 1 p plus 1 p minus 1 3 factorial. So, delta cube y minus 2. So, we are going to be substitute in this particular formula, we are going to be simplify. Just I will be substitution in the next slide. So, yp or whatever value we are finding f of 1936 we are going to be substituting the formula. So, I will be write the formula y naught p. So, this one we need to be remember like this p delta y minus 1 then p into p plus 1 by 2 factorial. So, 2 factorial delta square y minus 1. So, delta square y minus 1. Delta square y minus 1. Obviously, the next one p into p plus 1 p minus 1 by 3 factorial delta cube y minus 2. So, delta cube y minus 2. So, we are going to be substitute that values where y naught. So see the next previous slide. So the y naught value is 39. So we are going to be substitute 39. Where p value also we have done. This is negative minus 0.5. So minus 0.5 into delta y minus 1. From the table just we are going to be get this value, that is what the 12 value. So into 12. Then where p is minus 0.5 and minus 0.5 plus 1 by 2 factorial delta square y minus 1. Delta square y minus 1 is minus 10. So therefore minus 10. So minus 10 plus p into. So p is minus 0.5 minus 0.5 plus 1 minus 0.5 minus 1 by 3 factorial delta cube y minus 2. So delta cube y minus 2 also we are going to get from the table. So this is what this will be, okay, yeah. So delta cube minus 5 minus 10 minus 5 minus 15, that we are going to be substitute. So that we are going to be substitute and simplify, you are going to be get f of 1936. So to estimate that value easily, so whatever here actually 1931 is, the value is 27. So 1931 is 27, 1940 is 39. So therefore obviously that the answer is also lies between 27 and 39. So if you simplify, obviously we are going to be get 32.345 we are going to be get. This is the way we need to be find, estimate or interpolate the value easily. So if the value is located middle of the table, based on that value either we use the Gauss forward interpolation or Gauss backward interpolation value based on the p value. So in this lecture we discussed about Gauss forward and Gauss backward interpolation. So in the next class we are going to be discussed about Lagrange's interpolation formula. Thank you.